Per mi és un plaer presentar i ser el chairman de la primera sessió de les primeres hippie, titulada From Black Holes to Cookie Dunking, Theories in the Air. La primera xerrada serà portada a terme per el Xumeu Planells amb el títol Study of Parity Breaking in a Hot Dense Nuclear Medium.
Okay, hello everyone. I want to introduce you to the world of particle physics, which is the science that studies the elementary constituents of matter. We know that the human body it's made of tissues. The next level are cells, molecules, and atoms. And the atoms are made of electrons flying around the nucleus that is made of protons and neutrons, which are made of quarks. And these electrons are quarks, and quarks are what we call elementary particles, as we think that they have no further substructure. And it's important to say that all the main properties of all the known matter can be explained by the characteristics and the interactions of a very small set of elementary particles that I show here in this table. And the investigation of these particles is done in accelerator experiments, such as the well-known LHC in Switzerland and many others. The LHC, or Large Hadron Collider, is a circular pipe which has 27 kilometers of circumference. And there are collisions of protons and heavy nuclei, which are very carefully studied. Here I show you the picture of where the LHC is placed and the points where the main experiments are placed along the beam pipe. And in order to have an idea of how fast they move, imagine that instead of having protons, we give an ant, two ants, the speed of these protons. Then their combined kinetic energy would be 30 times bigger than the energy unleashed by the Hiroshima atomic bomb, but don't panic, the world is safe. And the nature, in principle, has four fundamental forces that explain the interaction of all the known matter, which are strong nuclear force, electromagnetism, weak nuclear force, and gravitation. And we will focus on the first one, the strong nuclear force, which is responsible of binding the protons and neutrons that are living inside the atomic nucleus, despite the electrostatic repulsion that you may expect from the basic. And these protons and neutrons living all together, this is what we call nuclear matter. And this nuclear matter can be well studied in heavy ion collisions, where it appears as a very tiny and ephemeral medium after the heavy ion collision. And in current accelerators, one knows that the temperatures reached in this small medium are as high as 100,000 times the temperature in the center of the sun, so quite hot. And here I show you a simulation of this heavy ion collision. They are approaching, and the final result and all the produced particles in this medium. The strong interaction shows a very important property which we call the parity breaking. It's something similar to a mirror reflection. And in these extreme conditions that I just explained you, this symmetry or this property may not be satisfied anymore. This is what we call local parity breaking. And our point is the following. Is it possible that there's a new thermodynamic phase of a strong interaction with this parity breaking? And here I show you a typical phase diagram, like the ones we know of water and other substances, where I plot temperature and density. And in different colors, you see different phases. And here, in very small, is where we expect that this phase may appear. Okay, so let's move to the experimental side. Here I give you a more complicated plot. This is the number of particles that are created from a heavy ion collision, depending on their energy. And, well, forget about all these curves here. The important thing is that the theoretical prediction that is made by physicists is the combination of all these curves, and it finally gives this solid black line on top. And the experimental data are the red points, and more or less you can see that everywhere fits except from this region here, which means that the theory behind here does not explain everything what happens. So the point is it possible that this parity breaking stuff that I just explained can explain at least partially this anomalous result? That's work in progress. Thank you very much.